In this video, we are going to be analyzing a vulnerability present on this Linksys E1200 router over here. It is present in the getMergeIP function in the HTTPD binary. Pass this binary to Ghidra. Now, select the function, navigate to Windows, function call graph. I have found that the following three functions, apply CGI, validate LAN IP address, and getMergeIP functions are involved in this vulnerability. Okay, so let's take a look at our first function, apply_CGI. So our goal will be to call the line, or to call the function on line 130. So basically this refers to the validate LAN IP address function, which we have seen to be the second function in the call graph. Okay, so let's start our investigations on line 112. So you can see a bunch of getCGI functions over here for the skip AMD check, action, and this variable over here, which, as you can see over here, relates to the LAN_IP ADDR variable. So basically CGI parameters are just values within the HTTP post request payload, which you can control via these named variables over here. So now let's take a look at the if statement for both the skip AMD check and action parameters. So this if statement checks if a certain variable is equals to 0x0, which basically refers to the null byte character. And if this variable is not specified in the payload, in the HTTP post request payload, this statement will succeed. Therefore, we have to omit this skip AMD check variable from the post request. While for action, if it's equals to the 0x0 null byte character, this variable will be assigned an empty value. Therefore, we just simply have to specify this field within the post request in order to bypass this if statement. Down below, we can see a string compare check between this variable and apply value. Therefore, this tells us that we have to give the string value apply to the action payload value. And with that, we'll be able to go past this if statement and enter this do while loop over here, which brings us into our intended code path right over here. But before that, we have to see that there is a nested if statement over here, which basically just checks if PCVAR5 is equals to the empty string. Therefore, we simply have to specify a value to PCVAR5, which is taken from the getCGI parameter, as we have seen before, of over here, yes, here. So this means we just have to simply specify a non-empty string value to this variable over here in order to pass the if statement, to fill the if statement, and enter the else block to call our intended validate LAN IP address function. So now just to show you that this line refers to the validate LAN IP address function, okay, once again, go to this variable over here, scroll down a little bit, and you can see right over here, memory address pointing to this function, yes, validate LAN IP address, which is the second function in our call graph towards the vulnerable function. And once inside, you can see another getCGI function for the LAN_netmask variable. And if this is equals to the null byte character, which means not specified, it will return from the function. Since we want to actually pass through this if statement, we have to specify this variable within the HTTP post payload. And with that, we are able to call our final vulnerable getMergeIP function over here, which contains the vulnerable strcat function. So in this function, it runs a while loop, which calls a snprintf function to craft a string variable, which is then passed into the getCGI function, which retrieves it to the __src variable, which is then passed to the strcat function without any validation or sanitization of the user input. Therefore, this means that a direct string variable on the stack itself is crafted directly using user input without any validation of the string length. Therefore, this gives rise to a classic case of stack-based buffer overflow vulnerability, which is actually very common on older routers like this. Comment down below if you'd like me to demonstrate how we can perform dynamic analysis to further investigate and exploit this stack buffer overflow vulnerability.